Hi everyone. We're going back to the first example in section 5.3, where we're solving this trig equation on the reals. We want all real solutions for this equation. Now, as a first step, we ultimately isolated cosine of x. You might want to substitute in the meantime. Let u be cosine of x, solve for u. But basically, we got this equivalent equation. And instead of solving the original equation, it's a lot easier to solve this bottom equivalent equation over here. Cosine of x equals root 2 over 2. We found the solution set for this equation. And there are different ways of writing it, but basically they corresponded to all the representatives for this northeastern point in quadrant 1 and this southeastern point in quadrant 4. All the representatives for this point, that is pi over 4 and all its coterminal twins. Also, this point over here, one representative is 7 pi over 4, or more conveniently, negative pi over 4, and also its coterminal twins. So all the representatives for that point. So there are at least a couple of different ways. In fact, there are infinitely many ways of writing the solution set well. Let's talk about some graphical implications. Again, we're solving the equation well, after our algebraic manipulations, we're solving the equation cosine of x equals root 2 over 2. And we want to know the real values of x that will make this equation true. In a way, we're solving the following system for x. We're solving the system, we'll talk more about systems later, but we're solving the system y equals cosine of x and y equals root 2 over 2. We're solving this system for x. Solve this system for x. And the y-coordinate is going to be root 2 over 2. The solutions for the system will correspond to intersection points between the two graphs. Where are the values of x that will make cosine of x equal root 2 over 2? And the y-coordinate will be root 2 over 2 at those intersection points between these two graphs. So the solution set for this equation consists of infinitely many solutions, real values of x, that correspond to where cosine of x is equal to root 2 over 2, the x-coordinates of the intersection points between these two graphs. Well, how do we graph y equals cosine of x? It's this cosine wave. Remember, it starts at a max point at x equals 0. It's also an even function, symmetric about the y-axis. If we graph y equals root 2 over 2, we get this horizontal line representing a constant function. And again, all the solutions for that equation, cosine of x equals root 2 over 2, will correspond to intersection points between these two graphs. All the points where both the red and the blue graph have y-coordinate root 2 over 2, which is about 0.7. Let's point at this point over here. Pi over 4, comma, the 0.707 is a rounding off of root 2 over 2. Likewise, over here, 7 pi over 4, comma, basically root 2 over 2. Remember, pi over 4, 7 pi over 4. Those corresponded to two solutions in our solution set. Where else did we get solutions? For what other x-coordinates? Well, I guess you can't keep points labeled if you slide things, but here we have pi over 4, comma, root 2 over 2. Guess what? Here's negative pi over 4, comma, root 2 over 2. Negative pi over 4 was also a solution. Remember, it corresponded to the southeastern point in quadrant 4 as well. So the representatives for this northeastern point in quadrant 1, pi over 4 and its coterminal twins. We have pi over 4. We also had these other points on the downswing, 9 pi over 4, that's on the downswing. Also over here, 17 pi over 4. Notice we have here pi over 4, and then if you add 2 pi, you get 9 pi over 4. You get that point. Intersection point between the red and the blue graphs. Also at 17 pi over 4, and so forth. Whoops. What about on the upswing? When this graph is going up, we had negative pi over 4, comma root 2 over 2. Also, remember, 7 pi over 4, comma root 2 over 2. That's if you add 2 pi to negative pi over 4. If you add another 2 pi, you get 15 pi over 4 over here. Or you could go to the left. Negative pi over 4 minus 2 pi gets us negative 9 pi over 4, corresponding to this intersection point here. So we can look at things graphically. Again, the solutions to the equation cosine of x equals root 2 over 2. The solutions to this equation are given by the x-coordinates of the intersection points between the two corresponding graphs here. Y equals cosine of x and y equals root 2 over 2. By the way, what if we just wanted the solutions between 0 and 2 pi? If we go around the world, we just have two solutions. The pi over 4, which I will put in blue over here, pi over 4, and also what? Also, not negative pi over 4, 7 pi over 4, and that's it. Between 0 and 2 pi, we only pick up two non-negative solutions, pi over 4 and 7 pi over 4. So if I had asked you to solve that equation, either this one or the original one we had, if I had asked you to solve it only on the interval from 0 to 2 pi, then this would have been your solution set. It would have had exactly two solutions corresponding to the pi over 4 over here and the 7 pi over 4 over here, because we're only allowing solutions between 0 and 2 pi for x. Next up, we'll solve for more trig equations.